This is a video covering lesson 3-3, parallel and perpendicular lines. In this lesson, you will learn to make conjectures about the slopes of parallel and perpendicular lines and use slope to determine if lines are parallel and perpendicular. You'll need to understand how to find slope from a graph and from 2 points in order to do this. So let's talk about slope. Slope is commonly referred to as the steepness of a line. And more specifically, slope is a number that is a ratio that describes the tilt of a line. You've probably seen the equation or the ratio rise over run to represent slope. And you should remember that rise is the up and down change of your line, right? And run is left to right, how your line changes or how it moves. So let's look at slope from a graph. If you have a graph of a line, you will notice that you can find the slope by looking at rise over run. You always want to identify 2 exact points if you want to find slope. So I can look at this point to this point, or I can look at this point to this one, and so on and so forth. But it has to be an exact point. In this graph, we notice that as we move from left to right, always start from the left and go right. As we move from left to right, we're going up 2, and then we go right 3. For every 2 we go up, we go right 3. So rise over run for this one would be 2 over 3. So there are actually 4 types of slope that we can have for a line. As we look from left to right, if the line is going up, you can notice the little guy walking up. That is a positive slope. If we look going down, if it falls from left to right, that is a negative slope. If it is very, very flat, just a flat line, horizontal line, it's a 0 slope. And if it's a vertical line, it's an undefined slope. When we are given 2 points, we can use the formula for slope that is y2 minus y1 over x2 minus x1. Notice the variable m. We always use the variable m to represent our slope. So now we're going to practice finding slope of 2 points, given 2 points on a line. First example says, find the slope of a line that goes through 2, 3, and 4, 6. So we're going to use our formula, m equals y2 minus y1 divided by x2 minus x1. And so for this one, this is x1, y1, and x2, y2. And we just set up our ratio. So the second y is 6 minus the first y, that's 3, over second x is 4 minus the first x, that's 2. 6 minus 3 is 3. 4 minus 2 is 2. So this slope is 3/2. Always check and make sure you have simplified your fraction. Okay, now pause the video and try the second example on your own. And after you solve for it, check your work. So after working this problem, you should have found that the slope is -4. Now complete these 2 problems on your own. Then check your work. You should have gotten -1/3 and -8/3. Notice if you only have one negative sign, the whole thing is negative. But if you have a problem where you have a negative on the top and the bottom, those cancel out. It makes it a positive slope. Now we're going to look at parallel and perpendicular slopes. We can tell if 2 lines are parallel by looking at the slopes, or we can tell if they're perpendicular by looking at the slopes. If lines are parallel, then they have the same slope. So notice here, this line has a slope of 4 over 3. This line has a slope of 4 over 3. These lines are parallel and they will never cross. Perpendicular lines have slopes that are negative reciprocals of each other. And what that means is negative means opposite. So if it's positive, make it negative. If it's negative, make it positive. Reciprocal is when you flip the fraction. You might want to write that on here. Flip the fraction. So if this first line has a slope of 2, we make it 2 over 1 so that we can flip the fraction. The reciprocal would be negative 1/2. So a negative reciprocal is where we, like we just said on the previous slide, flip the fraction and change the sign. So let's write some negative reciprocals or opposite reciprocals. If we have 2/3, the perpendicular slope to that would be negative 3/2. If we have 4, the perpendicular slope to that would be negative 1/4. If we have negative 4/5, the perpendicular slope to that would be 5/4. If we have 1, the perpendicular slope to that would be negative 1. The perpendicular slope to 0 is actually not a number, it's undefined, because remember, a 0 slope is a horizontal line like this. So perpendicular to that would be exactly like this to make a 90-degree angle. So that's undefined, a vertical line. And then for the last one, if we have negative 1/3 as our slope, perpendicular to that would be positive 3 over 1. So we just write 3. On this slide, you'll see a little flowchart that sort of helps you determine whether lines are parallel, perpendicular, or neither. So the first thing you do is you find the slope of each line. You'll be given 2 lines. And then you look and see, are the signs of the slope the same? If yes, then we check to see, well, do the slopes have the same number? If they have the same number, then they're parallel. If they don't have the same number, they're not. Then we look to see, well, if the signs are not the same, if one is positive and one is negative, then we check to see, are they opposite reciprocals, like we just talked about. If they are, then the lines are perpendicular, and if they're not, the answer is neither. So let's look at some examples where we determine if lines are parallel, perpendicular, or neither. In this first example, we're going to look at a line passing through -3, -1, and 2, 9, and then the other line passes through 4, 2, and -1, 8. So the first thing we do is find the slope of each line, and then we will compare them. So the first one passes through -3, -1. So let's find the slope. Remember, we're going to do y2 minus y1, that's plus 1 because it's negative, over x2, which is 2, minus x1, which is -3, so it's plus 3. So we get 10 over 5, which equals 2. Now we're going to find the slope of the second line, line B. This one was line A. Okay, line B passes through 4, 2, and -1, -8. So we'll do y2, which is -8, minus y1, which is 2, over x2, -1, minus x1, which is 4. -8 minus 2, that's -10. And -5 minus 4 is -1 minus 4 is -5. -10 divided by -5 is 2. So we compare our slopes, and the slopes are both the same. And so since they have the same slope, they are parallel. Let's look at another example. line A passing through -5, 5, and 0, 5. Okay, find our slope. You can go ahead and find the slope of that one. Okay, and we're also going to find the slope of line B, which passes through 2, -7, and 2, -3. I want you to pause the video here, find the slope of each of these, and compare them and see if they are parallel, perpendicular, or neither. And once you've answered, unpause the video to see how you did. Okay, so in this example, you should have found the slope of line A and gotten 0. When you go to find the slope of line B, you would get an undefined slope. So if you have a 0 slope and an undefined slope, then the lines are perpendicular. Next example says line A passing through -8, -5, and 4, 4. -8, -5, and 4, 4. Okay, and then we have line B, which passes through -8, 4, and 4, -5. All right, so we're going to find the slope of each of these. So go ahead and find the slope. Pause the video here and find the slope. Okay, so you should have found both slopes, and you will notice that the slope of line A is 3/4. The slope of line B is -3/4. So they're both negative. I'm sorry, they're not both negative. One of them's negative and one of them's positive. And so we know that they are not parallel, but when we compare them, if they were perpendicular, they would be opposite reciprocals. And they are not. They're the same except one is negative and one is positive. So what that means, it is neither parallel nor perpendicular. Go ahead and try these examples on your own and then check and see how you did. For these two, you should have found that both examples were parallel. In these last two examples, we're going to find the slope, then we're going to graph it to verify that they are parallel, perpendicular, or neither. So for the first one, let's go ahead and find the slope. So for both of these lines, you should have a slope of -1/3. So let's go ahead and graph the points. The first one, A, we'll do in this color. So 1, 5, right one up 5, point would be here. And 4, 4 would be here. And we can go ahead and draw that line. May or may not be very straight. The next line I'm going to do in blue. So I have 9, -10. I think it's hard to see. Sorry, let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there. Okay. And then the other point is -6, -5. So left 6. Okay, and that's there. And you can kind of see, if I can draw a straight line, that the lines here are parallel. They will never intersect. Okay, go ahead and do the next example on your own. Pause the video here, complete that example, and then check your work. So we can see on this slide that these lines are also parallel. So in this video, you learned to make conjectures about slopes of parallel and perpendicular lines and how to use slope to determine if lines are parallel or perpendicular. And you will show that you can do this skill and that you've mastered it by completing independent practice to at least 85%. Thank you for watching this video.